circular permutations. The permutations are known as circular permutations. Now, in circular permutations also we have two subparts. The first part is when clockwise and anti-clockwise arrangements are distinct. Arrangements are distinct. What does it mean? It means when we can differentiate whether we are arranging the things in clockwise direction or in anti-clockwise direction, then the number of circular permutation is equal to n minus 1 factorial. Second point, if clockwise and anti-clockwise arrangements are not distinct. Arrangements are not distinct. It means we cannot distinguish whether we are arranging the things in clockwise direction or in anti-clockwise direction. The example for this is arrangement of beads. This is very important. Arrangement of beads in necklace. Then the circular permutation is half n minus 1 factorial. When we cannot distinguish whether we are arranging the things in clockwise direction or in anti-clockwise direction, the example can be arrangement of beads in a necklace, then we are to take the circular permutations as half of n minus 1 factorial. Now, let us do one question of circular permutation. Write down, there are 5 gentlemen and 4 ladies at a round table. In how many ways can they seat themselves so that no two ladies are together? Now, let us read first of all what is statement. There are 5 gentlemen and 4 ladies. We are to make them sit around the round table. In how many ways they can sit themselves that no two ladies are together? Now, we know 5 gentlemen can be seated at a round table in 5 minus 1 factorial, that is 4 factorial ways, because we can distinguish whether we are making them sit from the clockwise direction or in the anti-clockwise direction. When 5 gentlemen have occupied their seats in any of these 4 factorial ways, then 4 ladies can occupy any 4 out of any 4 out of 5 seats by any can occupy any 4 out of 5 seats. Any 4 out of 5 seats. Let us see how. We have 5 gentlemen. Let make them sit round the table like this. 1, 2, 3, 4, 5. Now 5 gentlemen in between, how many spaces are left? 1, 2, 3, 4, 5. And there are 4 ladies. They can be seated, occupy 4 out of 5 seats between men in 5p4 ways. Hence, required number of ways is equal to 4 factorial into 5p4, and value of 5p4 we know is 5 factorial. 4 factorial is 4 into 3 into 2 and 5 factorial is 5 into 4 into 3 into 2. We get this as 24 into 120 and this comes out to be 2880. This was the question of circular permutation. Now, let us come to the last point, combinations. What is a combination? A combination is a group or selection of number of things taken some or all at a time. And notation is NCR, or we can write this as C by taking C outside, N comma R. Formula for NCR is, NCR means N factorial over R factorial into N minus R factorial. And then we have some results. Write down the results. First result is NCR is equal to NCN minus R. Second result, if NCX is equal to NCY, then either X is equal to Y or N is equal to X plus Y. Third values we must remember, the value of NCN is 1, value of NC1 is N and value of NC0 is 1. We are going to make use of these results in our questions. Now, let us do first question of combination. If NC10 is equal to NC12. Find N and evaluate NC5. What is question? Question is, we are given NC10. This is given as NC12. We have just written the result number 2. If NCX is equal to NCY, then either X is equal to Y. What does it imply? This implies either 10 is equal to 12, which is not true, we know. Therefore, N is equal to 10 plus 12. That is, N, value of N comes out to be 22. Now, the first part was we have to find the value of N, and that comes out to be 22. Now, we have to make use of this value in order to find NC5. Let us see how we do this. We are now 22C5. We have to apply the formula of NCR. What was our formula? NCR is n factorial over r factorial into n minus r factorial. Here, instead of r, we have 5. Now, let us apply the formula, and n is 22. This means this is 22 factorial over r. R is 5 into 22 minus 5 factorial. This we get as 22 factorial over 5 factorial into 22 minus 5, that is 17 factorial. Now, question is how to solve these factorials. In the numerator we have 22 factorial, in the denominator we have 17 factorial. We will expand 22 factorial in terms of 17 factorial. This can be written as 22 into 21 into 20 into 19 into 18 into 17 factorial. And in the denominator, 5 factorial means 5, 4, 3, 2, 1, and 17 factorial as such 17 factorial. Now, we cancel 17 factorial from numerator and denominator. 5 4 20, this cancels with this. 3 2 6 6 3 18. We are left with 22 into 21 into 19 into 3. Multiply 22 by 21, we get 462 into 19 into 3, that is 57. When we multiply, we get the answer as 26334. This is our answer. This was all about the combinations. Now, let us quickly recall what we have done today. The two results we must remember. The first is of permutations, NPR. This means n factorial over n minus r factorial. And the second result that we must remember, that is NCR. This is equal to n factorial over r factorial into n minus r factorial. That was all about the topic of permutations and combinations. Thank you.